What's up YouTube? This is the second video of the tutorial um, uh, of the tutorial um, which I have been explaining how to read an encoder using your Arduino. So in the previous video, this is the second video, and in the previous first video, I have explained up to uh, this part, and in this video, I'll be explaining the rest of the code. So after this, we have to uh, attach let me just finish typing and then I'll explain. Okay, so what I have done here is that I have created an interrupt for digital pin 2 and digital pin 3. So but it basically does is that inside the Arduino it will it will create a separate thread to watch over that digital pin. uh, uh, the, it will be done separately while the code is executing, but while the main code is executed. So this will be run on separate thread, and it won't affect the process of your main code. And so, and there are and how you do that is you need to provide three parameters. uh, the first thing is the pin which you want to assign the interrupt, and there are different way to define it. In different tutorials they have used different methods, but this is the most appropriate method recommended by the Arduino official website, because in this way when you use this digital pin to interrupt syntax, you can within the brackets you can provide the uh, provide literally the whatever the pin number printed on the board instead of finding the mapped pin number. So this is the best way to provide the pin number for the interrupt, and this is the function which we want the compiler to run once it sends an interrupt. So when there's an interrupt, when a signal is received by this digital pin 2, it will trigger this function, which is this function, and do whatever is inside that function. And what sort of in the third parameter we specify what sort of a interrupt are we are expecting. Is it a rise or a fall or a change? So you can, if you want to read more about these interrupts, I would suggest you to read this uh, this page in the Arduino official website uh, for reference, for future reference, and I'll be leaving the link down in the description if possible for you to check it out. And now you are basically done with the code. So when you run this code, what will happen is that you will be this current position variable will be recording uh, every single uh, uh, signal which comes from the encoder, and if it is a if it is so it will consider one direction as positive depending on how you have connected encoder pin A and encoder pin B. So whatever that you have to find it out, you can find it out by printing the current position value with what direction is considered as positive. And so depending on the direction that the encoder is rotating, it will increase or decrease the value of this current position variable. And so but the problem is when you are using this an encoder in your mechatronics project or a robotic project, the current what you have in this variable is the pulse count you get from the encoder, but you can't get a physical meaning out of this variable. So when we use an encoder, we use it to measure the rotation angle of something. So for that, I'm going to show you how to convert this signal count into the rotation angle, so that you can use that data for your whatever the project you are doing. So it's just one simple line. Yeah, this is it. Using this simple line, I forgot to declare the variable. Let me just declare it first, like this. So um, so what this does is that this will take the current position variable and give you the physical angle in degrees uh, of that give you the current position in degrees respect to the with respect to the position you initially started. And that's it. That will be it for the tutorial. And if you have any questions, feel free to um, drop a comment below, and I'll help you out as soon as I can. You can always contact me. And if you want any other tutorial which you want to see in my channel, please let me know. I'll try my best to make one for you. And see you next time.